Okay, topic 2.0 Kinetic Molecular Theory. So, kinetic molecular theory is the backbone for all gas laws. All scientists derived their gas law relations based on kinetic molecular theory. Okay, so kinetic molecular theory explains the behavior of gases by describing how they are moving. Okay, you need to know they are continuously moving. During their movement, what they are doing and how their behavior impacting the properties of gas. Okay, almost all properties are, all postulates for the theory are written for you, but I'm going to highlight or write important thing from that. First thing, according to kinetic molecular theory, we know that if there is a container or every single time, okay, in our room, okay, all gas molecules are continuously moving in straight line, random movement. During their movement, they will collide with each other and also with the walls of the container. So we can describe their movement in a very important way, which is random, constant movement. They will never stop. Okay, that is the first postulate. Gas particles are always moving in straight line. That is important, okay? And they will do what? They will collide with each other and also with the walls of the container. Okay, second one about the volume, okay? So we know that gas need a lot of space to stay, like because they are separated, okay? So, because of that, the total volume is very high and each molecule is small. The volume of gas particles are small, so we can just assume the volume of individual particle is zero. So, volume is negligible. Negligible means we don't need to consider compared to the total volume of the gas. Okay, say for example, if you are in a football stadium, say you are in Star Stadium, right? And that it has maybe 5,000, I don't know how many, 6,000 chairs there, and we are going to sit in that room, like 28 students from our class. Okay, so we can, like, maybe there are 6,000 seats there, you have a lot of choices to sit there, right? If I remove one of you from that auditorium, it won't create much space because it's already there is a lot of space. It won't change it. If I am bringing one more person there, it won't affect that. But if it is a small classroom, my classroom has 30 seats, okay, and I have 30 students. If I remove one person from my class, then there is a space created, okay? Or if I am bringing one other student into my class, I have to find a chair, right? So that means that volume matters. So in the case this is a gas, or we can say this is a solid. In the case of gas molecule, the volume is negligible because we have a lot of space and each molecule is small. Volume of gas molecule is negligible. There is a comparison, right? Negligible compared to the total volume of the gas. Okay, now we said the molecules are continuously moving, and during their movement they are colliding with each other. But they are always moving until the end of the universe. Why? Because they will never lose their energy during collision. Or we can say molecular collisions are perfectly elastic. Collisions are perfectly elastic. That means they won't lose or gain energy. Their total energy always remain constant. So next one about the intermolecular force. We already said gas molecules are very further away. So their intermolecular force will be very small. So we can say they have zero intermolecular force, or they have very weak intermolecular force. Then next one, we already talked about that kinetic energy, that is Ke, always depends on what? Temperature. If a colder day, they have low energy. Okay, if a hotter day, the gases will have higher energy. Okay, now let's go ahead and highlight the important factor we discussed, or we can apply. Kinetic energy of gas molecule completely depend on temperature. Higher the temperature, higher the kinetic energy. If oxygen and hydrogen are at the same temperature, doesn't matter whether it is oxygen or hydrogen, they both will have same kinetic energy, because kinetic energy depends only on temperature. Okay, same temperature means same kinetic energy. Then if we have two particles like hydrogen and oxygen, we know that hydrogen has a mass of 2.02, it is diatomic, and oxygen has a mass of 32 gram. This is a lighter particle and this is a heavier particle. According to kinetic molecular theory, lighter particle will move faster. Okay, read this. And heavier molecule will move slower. Okay, now we are going to discuss two properties. You are familiar with that property. If you have something in this room, like if someone is eating in popcorn in our class, we all will recognize, oh, someone is eating popcorn, right? Because the smell is spreading the room very fast. That is called diffusion. Okay, so spreading of a gas through the space, that is called diffusion. Then if I am spraying a spray bottle, we know that the gas will escape through a tiny hole, right? That is called effusion. And both effusion and diffusion follows kinetic molecular theory. That means higher the temperature, they will move faster. Say for example, a smell from hot coffee reach your nose faster compared to something which is cold, right? And they also depend on the size. Okay, if the molecular size is small, then speed will be higher. Okay, so speed, we can say rate, will be inversely proportional to the size. Smaller the size, higher the speed. Okay, now there is practice. You have to do that as classwork, but I am recording the video, so I am going to write the answers. Okay, since those who are absent will not get a chance to discuss this. So what I'm going to do, what you are going to do, right? You can stop the video and do it and check it later. Okay, so according to kinetic molecular theory, you have to tell me which one is correct. If it is false, correct that by underlining and crossing out the wrong word. The particles of gas are in a constant organized motion. I would say no, it is not organized. We already said the gases are always in a random motion. So this is false. Now it is correct, okay? And gas particles travel in straight line. Yes, that is correct. I'm going to write this. So this was false. Gas particles are tightly packed. What do you think? No. It is what? Loosely packed. They are spread apart. Particles in a gas are highly attracted. I would say that is also false, because they are what? What about their intermolecular? Weak. Collision between gas molecules are perfectly elastic. Yes, they are. It is true. Gases are most dense. Density is the mass over volume. If volume is higher, that means density will be lower. That means it is wrong. So they are the least dense state of matter. Then average kinetic energy of gas particle decreases when temperature increases. That is wrong. It is what? it is increases because proportional to temperature. Okay, then there were 3 homework given there. Why would a pressurized spray can possibly explode left in a hot car? This is where we are like connecting gas laws or whatever we learned in kinetic molecular theory to our real life examples. Okay, so we know that in a spray bottle there are molecules which is continuously moving and it has a particular pressure because collision is the pressure, right? When temperature increases, what will happen? The kinetic energy will increase. That means each particle will get more energy. They will move faster. So they will collide more. So their what will increase? Their pressure, gas pressure will increase and it will explode. Okay, next one is student hypothesize fluorine gas will exert less pressure than okay, that's not same size, than a sample of bromine. It says same sized container, right? Okay, same temperature, at the same temperature, because fluorine atoms are more electronegative. I would say that is a wrong statement. Okay, it is more electronegative because it is more electronegative, but see, we already learned gas molecules have what they have weaker intermolecular force. Okay, so if they are in the same temperature, their kinetic energy will be same and their pressure will be same. So that is a no. Because the intermolecular force will be the same or they have almost what intermolecular force? 0 intermolecular force. And kinetic energy depends on same temperature. It depends only on temperature. Okay, here. Fluorine gas will diffuse faster than sample of I2 because molecules have greater atomic size than F2 molecule. That is true. We said rate of diffusion also depends on the size. Okay, smaller the size, higher the rate. So that is right. Explain. Because fluorine is smaller than bromine, no idea, whatever. Okay, now there is the final part, which is gas laws. Okay, so all the example, I will discuss example. You have to find your own example. Don't write my example here. Okay. So first gas law. So gas laws means we are discussing the relation between pressure, volume, number of moles and temperature. That is gas law. Okay. First one we already discussed Avogadro. Remember the balloon, more volume, more gases, more volume, right? So volume is directly proportional to number of particles. When moles increase, volume will increase. When moles decrease, volume will decrease. So this relation, I will write one more time, okay? So V1 and N1 will be a constant, will be equal to V2 over N2. And this is a relation we are using for calculation. And since it is proportional, we will call that relation, what is it? Directly proportional. If we draw a graph, we already did, okay? You can put V here or N here. I will do the other way, okay? Both will be work. N, V. So when N increases, V will increase, we will get a linear graph. Example, think about an example from your daily life, or like breathing and breathe out. You can see when you breathe, okay? So I said you have to write your own an example. When you breathe oxygen, your lung will do what? Lungs will expand, right? When you breathe out, they will shrink. Okay. Another one, second gas law is Boyle's law. Boyle. Okay, so we'll write A, B, C laws. Boyle said when I will always write everything in volume so that will be easy for you to learn. So Boyle's law said when volume pressure increases, volume will decrease. That means they are inversely pressure. Volume increases, pressure do what? Decreases. Volume decreases, pressure do what? Increases. Okay, that means this is a relation you are going to see. P times V1 is equal to P2 times V2. This relation is called what? Inverse relation. So when you have a graph, V goes here, P goes here. When pressure increases, volume will decrease. Okay, so now think about an example, okay? In class, we did an experiment, but since you are watching this, we can say if you have a syringe, okay? Okay, I can't draw. Okay, when you push the piston down, the plunger down, what you will feel? You will see more difficult to push that down. That means there will be more pressure. Or it's like imagine if you have a balloon, if you are blown balloon, if you are reducing the size, you can feel more pressure. Okay, and come with your own example. Another one, which is Charles' law. Charles' law says when you heat a gas, when you raise the temperature, condition, there is always condition, okay? Here, all other properties will be constant. We are talking about V and N, then P and V will be not changing. That means they are constant. Here we are talking about P and V, so N and T will be same. If you are talking about V and T, then P and V will be same. Then only we can apply that, okay? So when you are heating, like say for example, if you have a balloon, if you are keeping the balloon in the refrigerator, it will shrink. Or if you are heating a balloon in a boiled water, we are dipping in a boiled water, the balloon will expand, okay? When temperature increases, volume decreases. No? No. When temperature increases, volume increases. When temperature decreases, volume decreases. Okay, so if you have like a birthday party outside on a cold day, all the helium balloons you brought from the store will shrink. Okay, if it is a hot day or if you are taking that inside the room, that will again expand. Okay, and that relation is also direct. All other laws are direct. Okay, so we can write when you apply pressure, it's not pressure, temperature. When you apply when you heat a gas, the volume will increase. Okay, write the example for a balloon. Next one is Gay-Lussac's law. So here we are going to talk about completely different. What are the odd ones now? Pressure and temperature. Okay, now V and N is constant. When you increase the temperature, keeping volume constant, that means you are using a rigid container. So balloon is a flexible container. It can expand, okay? Flexible, remember. But rigid means like if you have a metal container, right, it is a rigid container, it has a fixed walls, it won't expand. So volume will be constant and it is closed completely, so number of moles is also constant. But you're heating the metal can. What will happen? When you heat, kinetic energy increase, they will move faster, they collide with the higher energy, so their temperature, their pressure will increase. That is called Gay-Lussac's law. So when temperature increases, pressure decreases. When temperature decreases, pressure... Why I am writing the wrong ones? Okay, when temperature increases, pressure increase. When temperature decreases, pressure decreases. So that is also direct relation. I said only one law, which is Boy. Boy is the only one which is inverse. So pressure and temperature, then they will get a direct relation. And you can, example, okay, we know that during winter, okay, your car will show low tire pressure. Reason, when temperature outside, atmospheric pressure during the snow time, you might have seen that the temperature outside is decreasing. That means tire is a fixed volume, right? So the increase, that will decrease the tire pressure. So that's why we will go to the store, add more gas there. So that is an example for Gay-Lussac's law. Okay, now what you are going to do, you have 2 pages of practice. So each gas law, each real life example, you have to identify whether it is Boyle's, Charles, it says volume of a gas and pressure increase, so that will be Boyle's, and you have to explain using particle motion. Okay, so it is asking what will happen when pressure increases, what will happen to the volume. You have to explain when pressure increases, molecule will come more closer. That means the container will shrink, so volume will decrease. You have to explain in terms of molecular nature. Explain. So these two are homework. These two means these 2 pages are the homework. Finish that.